What's going on? It's Cooper Codes, and in this video, we're going to create a GraphQL API with Apollo Server and MongoDB Atlas. We're going to first create a recipe database model using Mongoose, and then we're going to design all the CRUD operations for the recipe model in our Apollo Server. So that's create, read, update, and delete. We are going to create new recipes with a name and description. We're going to read recipes, such as getting a recipe's information from its ID or a list of the most recent recipes. We're going to update a recipe with new information, such as updating it to a different name, and we're also going to delete recipes from our database based off of their ID. If you're new to GraphQL, Apollo Server, or even Mongoose and MongoDB Atlas, this video is going to be a great introduction to all of those concepts, and it should get you ready for deploying and creating your own GraphQL APIs, even if they aren't this specific recipe API. So before we get into code, I'm going to talk about how does Apollo Server actually work with MongoDB. There's this technology called Mongoose, which allows us to create MongoDB models. So a Mongoose model for a recipe would have something like this. It would have a name, a description, a created at, which would be a date, and maybe thumbs up and thumbs down, which would be numbers. The Mongoose model allows our Apollo server to interact with MongoDB because we can use this model to then save it, find instances of this model in our database, and a bunch of things like that. The most important part about the Mongoose models is that it's telling our database how the recipe data should be structured. If you have recipes in your app, for example, you want them to all be structured the same way, and Mongoose helps us with that. So in our Apollo server code, we can use the Mongoose model directly. So we can use any functionality that is in the actual Mongoose documentation. This includes recipe.save to save your recipe to your database, and maybe recipe.findById to look at all the different recipes in your database and see if they match a certain ID. Mongoose has a bunch of functions that I'll go over in this video, but the important part is that there's a bunch of Mongoose documentation. If you want to look at any of the specifics of Mongoose, just look up Mongoose documentation on Google. All right, so let's get started. The first thing we're going to need to do is to go to MongoDB Atlas, which is a fully managed MongoDB database that's 100% free. So go to MongoDB Atlas, just look it up on Google, or go to this link here and then sign in. So once you're logged into MongoDB Atlas, you should be on these database deployments by default, but if not, press Atlas and then press Database here, and then press Build a Database. You want the free options, so we're going to go to the right here and press Shared. The only thing you have to do here is choose the region that is closest to you, and then you should be good to go. You're then going to need to create a username and password to access your database. So I'm going to say Cooper and then codes for mine. So the password is Cooper and codes if you want to follow mine, but do whatever username and password you want. And then just press create user. It should show this by default, but make sure that your IP access list on the bottom here has all these zeros like you see here. This pretty much means that any IP can access your database, which is good for just a development and testing environment. So once you're done with that, you can press finish and close. You should be brought to this database deployments page by default. Just press connect here, then go to connect your application. And then you're going to be given this string right here. This string is incredibly important and you're going to want to save it. So save it in a text file, wherever you want to save it, as this is the string that we are going to use to connect to our MongoDB Atlas. And once we have this string, we're all good to go on the MongoDB stuff. Everything is fully set up for us, and now we can get started by creating some actual JavaScript code. All right, so use whatever text editor you want, and we're going to go to our terminal and make sure you're in the same folder as your text editor. I'm going to do npm init -- yes. What this does is it gives us an empty package.json. This empty package.json is important because we're going to want to install a couple things using the npm node package manager. If you don't have npm installed, just go look up install npm or install node.js, and it should be a relatively easy process. So in the same folder, we can then say npm install apollo-server for the Apollo server code, GraphQL for the GraphQL code, Mongoose for Mongoose like we discussed before, and then nodemon, which is going to help us refresh our server whenever we make any code changes. Inside of our package.json, I'm going to make a start command, so we can go in here and we can say start. And what this is saying is if we run npm start, which command do we want to run? So when I run npm start, I want it to show nodemon index.js. Index.js is a file we're about to make, which is going to run our server code. So it's pretty much saying run our server code using nodemon. So this command is pretty much saying run our server code index.js on nodemon. So make sure you save your package.json, and then we can go and make that index.js file. So index.js is going to hold where we do all of our server things, such as implementing the server and making sure everything is running and connected. So the first thing we can do is we can say const Apollo server is equal to require apollo-server. This is getting the Apollo server object out of the library for Apollo server. Then for the same thing, we're going to say const mongoose is equal to require mongoose here. So this is just giving us access to mongoose from the mongoose package. We are then going to make a const for that MongoDB string we created before. So I'm going to call it capital MongoDB. So go back to your MongoDB or wherever you saved it before and get this string here to connect to your server. Then you're going to want to change the string to have your username and your password. For example, my username was Cooper and my password was codes. If you have any trouble authenticating to your server, triple check your username and your password. So our Apollo server requires two different parameters to run. The first one is the type defs, which is your GraphQL type definitions. So what are the actual GraphQL types? What are the GraphQL queries? Things like that. And then our resolvers, which is how do we resolve queries / mutations, which are the two main ways to interact with your Apollo server. And so we can create this Apollo server by saying const server is equal to the Apollo server constructor. And it's going to take in two parameters. It's going to take in the type defs, and then it's going to take in the resolvers. The type defs and resolvers are something we are going to create later in this video, but they're going to exist in these folders. Const type defs is equal to require. Then we can say in this directory, go to the GraphQL folder, which we're going to make, and then go to the type defs file we're going to create. Then we can also point to where our resolvers are going to live eventually. And we can do that by saying require / which means this directory, GraphQL again, /resolvers. And just so you guys get some context, the main chunk of our code is going to exist in the typedefs and resolvers files. So that's why we're pointing this Apollo server to kind of start from these files. We also want our Apollo server to interact with things using Mongoose. So we have to do a mongoose.connect. We're going to pass in our MongoDB URI string, which is this string right here, which is saying connect to this database specifically. And then this is just some code that's in documentation, but use new URL parser is true. And then we can say .then. So when the connection is done, we can do a little arrow function syntax here to create some code to show when the connection is done. We can say console.log MongoDB connection successful. And then we can return a server.listen on, let's say, port 5000 for our server here. When our Mongoose is successfully connected, we then want our Apollo server to start. I'll explain more of the Mongoose stuff later as it makes more sense in actual practice, but pretty much we want Mongoose to be connected first because our Apollo server needs to use Mongoose to talk to MongoDB. We can then do another .then statement because this return server.listen is going to give us a response right here, or result, sorry. And so with this result, we can show where the server is actually running. So we can say backticks server is running at $res.url. And this is pretty much using the response from the return server.listen, and the backticks allow us to do this $sign syntax to use a variable inside of our string. This is just to show that we are actually running a server at localhost 5000, for example, is what this res.url is eventually going to become. So this is great news. This means that we have our Apollo server getting started and our Mongoose getting successfully connected. If we try to run our code right now, you're going to see that typedefs and resolvers are both not defined. I'm going to define these in a second, but I think it's important to first look at what does a Mongoose model actually look like. So let's go into our directory here and make a new folder called models. This is where our Mongoose model is going to live. So if we're going to make a model for the recipe, we can call it recipe.js. So the creation of the Mongoose models is relatively simple. We're going to get the model and schema out of our Mongoose package here. So we can say require Mongoose. And this gives us access to both the Mongoose model and the Mongoose schema. So if we want to make a schema for recipes, we can say const recipe schema is equal to new schema, which is going to use a schema constructor. And then we can pass in any of the properties we expect to have in the recipe schema. So for example, the name is going to be a string type. The description is also going to be a string. The created at is going to be a string. So like created at a certain date, for example. Then we're going to have thumbs up, which we're expecting to be a number. Then also thumbs down, which we're expecting to be a number as well. This is a basic idea of what a schema would look like for a recipe, but for whatever you're doing, you can always look up Mongoose schema properties, and it will show you all the different things like strings and numbers, and you can get a bunch of great examples to base your own, maybe different model off of. But for this tutorial, we are good to go with this recipe schema. We can then do a module.exports to pretty much send data out of this file if we ever want to use recipe.js. We are going to export the model constructor with a name of recipe, and then the actual schema of the model, which is going to be the recipe schema. And so now we are fully set up on the Mongoose side. We have a Mongoose model, which we can then use to save data to our MongoDB database. So if we go back to our index.js, we have this typedefs and resolvers, which I kind of went over before. So let's create this GraphQL folder and make the typedefs and resolvers. So we can go to the new folder here. We can say GraphQL, and let's start by creating the typedefs.js. So typedefs are pretty much saying what are the GraphQL types we're expecting to have in our Apollo server. So typedefs is more of a GraphQL concept that Apollo server uses. And typedefs are created by using this thing called GQL, or the graph querying language. So we can import GQL by saying const GQL is equal to require Apollo server. So from here, we want to say module.exports is equal to GQL and then backticks. Anything in between these backticks is going to be looked at as GQL code. We're not in JavaScript land anymore. We're actually being kind of rendered as graph querying language, if that makes sense. And so we can get started by creating our first GraphQL type. We can start by saying type recipe is then going to have the property of a string with the name. The description's also going to be a string. The created at is also going to be a string. Thumbs up is going to be an integer. The integer here is a subtle difference. In our Mongoose model, we saved it as number, but in GraphQL, it's expected to use something like integer, for example. So that's another strange thing about working with Mongoose models and then the actual GraphQL types is sometimes the names aren't one-to-one the same. You have to be kind of creative, kind of going back and forth between them. Then we can make the thumbs down also be an int. And so this is great. We have our first GraphQL type. And this GraphQL type is important because it allows us to do things like have a GraphQL resolver, for example, get recipe, and then we're going to return a recipe based off of this schema here. So in our GraphQL API, we can do things like I have this recipe type I'm expected to get returned, and I only want to get the name and description out of this type specifically. That's why these GraphQL types are so important in your typedefs, is that when you do things like return or you do things like parameters to your resolvers, you're going to run into things where it uses these GraphQL types. Alongside types, GraphQL also allows us to have things like inputs. So we can say input, recipe input. You could imagine if a user was going to create a recipe, right? They're going to only input the name, which is expected to be a string, and then the description, which is expected to be a string. The thumbs up and thumbs down are going to have some default values of 0, and then the created at is going to be created on our server. You wouldn't expect a user to manually type in the exact date and time they created their post, right? So this input here is generally what the user is going to input from your front end. And so the typedefs are also going to have queries. And so the query is super important here. Queries are kind of like the read part of create, read, update, delete. It's getting information and reading information. So a super simple query we can make is a recipe where you pass in an ID type and you get back a recipe type. And this exclamation point just means that it has to have a recipe and this ID has to exist as well. We can also make another query called get recipes, where it has the amount of recipes you might want. So let's say I wanted to get 5 recipes. I can make that an integer, and I'm going to get returned a list of recipes. These queries are important because we are going to then create resolvers code. So I'm writing out all of these queries and eventually all of these mutations to show you guys the overlying concept of what we're going to build. And then we're going to go into Apollo server and create them one by one. So down here, I'm also going to make some mutations. And so queries and mutations are the main ways you can interact with your Apollo server. Some examples of mutations we're going to make are the create recipe. And so if we wanted to create a recipe, we would have to take the recipe input parameter and then get the input from up here. So what this code right here is saying is use this recipe input variable and make sure it's of the type recipe input, like from line 12 to 15 here. And then we're going to want to return the created recipe here. We can also make a mutation to delete recipes. So I'm going to say delete recipe right here, and we can delete them based off of an ID, for example. So I'm going to say ID is equal to the ID type, and it has to show up. So that's why I use that exclamation point, is if it has to be there, we use exclamation point. And then I'm just going to return a Boolean for this application saying if was something deleted or didn't exist. It's kind of a simple way of doing this. It's also possible to get the recipe you deleted and then return a recipe like this here. But for this application, I'm just going to make it simple and make it a Boolean, which is going to be true if something was deleted, false if the ID didn't exist, or if anything wasn't deleted, for example. I'm also then going to create an edit recipe. So edit recipe is probably the most complicated one because you're going to first need the actual ID of the recipe you're editing. So we're going to do similar syntax here where you have the ID parameter. Then you're also going to need that recipe input, and it's going to be of type recipe input like above. This is just because imagine if you wanted someone to change the recipe. they can change everything, for example. So let's just say they wanted to change the name and the description, and you had a front end, for example. Well, you just make the editing look very similar to the initial creation of your actual recipe. And so you can edit anything that's inside of this recipe input, which would be the name and the description. So if someone wants to edit their post, they can then edit the name and the description, is pretty much what our code is saying here. And we can return a Boolean showing if it's been edited or not. I think an interesting side note on this is, let's just say you wanted them to never be able to change the name of their post. You could create another input type where it's like edit recipe input, and then just only have the name, for example. And then you can make this edit recipe input, edit recipe input. I'm not going to do that for this video, but I'm just showing you guys as an example for now, something you might want to do if you want the attributes they can edit to be different than the attributes they can create on that initial creation. So I'm going to undo all this, but just show you guys an example. All right, so we have now fully created our type test for our application. We can now create a resolvers.js file. So in this resolvers.js file, we're going to hold all the different resolvers for our application. And so what is a resolver in Apollo server? It's pretty much the functionality behind any code that you've initially defined in your type defs. A great example is, let's say, create recipe. There's going to be a resolver for create recipe. There's no real functionality here. We're just saying that this mutation is eventually going to exist. And so the resolver is, how do you actually create that recipe and how do you return that return type to the recipe here? And so that's what I mean when I say resolver. And so resolvers are going to be in two main types, which is going to be queries and mutations. So we're going to create all the different queries and mutations necessary for our Apollo server in this resolvers.js file. So some initial setup, we're going to have that const recipe is equal to require ... models/recipe. This is giving us access to that recipe model we created before. Now we're going to structure out our module.exports. So we can say module.exports is equal to an object, and this object is going to have two things: a query, which is going to have all of our code for the queries to our application or to our Apollo server, and then a mutation, which is going to have all of the resolvers for the mutations as well. So we can get started by developing the queries for our Apollo server. So I'm going to make an asynchronous function. So for the queries, I'm going to take a look at our type defs and take a look at the first query we're going to develop. So it's going to be the query to resolve the recipe here. And so this recipe has to have the same function name over in our resolvers. So I'm going to make an asynchronous function named recipe. I'm going to ignore the first parameter in Apollo server. So Apollo server resolvers have 4 parameters. The first one is the parent. We don't have to use the parent for our case, but the second one is the arguments, which we do have to use. This is like the parameters being passed into our resolver. The argument is going to be an object, and so we can use some object destructuring syntax, and you can look that up online, object destructuring, to get a better idea of that. And it's going to give us that ID. So we can say ID, and now inside of our resolver, we're going to have access to that passed in ID right here. And we can finish this up by putting some curly braces at the end. The reason why our function is asynchronous is because that we're going to use an await statement when dealing with Mongoose. So to get a recipe based off of an ID, we're going to start by using our Mongoose model. And so we're going to return await recipe.findById, which is a function given to us by Mongoose. This is a super important part here, is it's given to us by Mongoose. And what is this expecting? It's expecting an ID for its first parameter. And so what this await recipe.findById statement is going to do is it's going to wait for Mongoose to give us a response to us attempting to find a recipe based off of a certain ID in our database. Once it finds that recipe, it's going to then return here. So when we get a successful response using this resolver, it's going to look at our recipe model, see if there are any recipe kind of blocks of data that match a certain ID. And if there are, it's going to return that statement here. And so this is a great example of a pretty simple query because that's all we have to write. If we pass in an ID that exists, it's going to give us the recipe data for that ID. And just to go one step further, we can take a look at our type defs again. And when this recipe here gets that returned recipe, this is where the power of GraphQL also comes in. Since this recipe is being returned based off of the type over here, we can ask for maybe only the name and the description in our GraphQL query. Or we can ask for only the thumbs up and the thumbs down in our GraphQL query. That is where the GraphQL aspect of Apollo server comes in, is when we get this recipe type here, it's being returned in a way that is just like this type recipe here. And so we can do the same thing where we only ask for certain properties out of this certain type. And I will show you guys examples of this later in the video. And so let's go back to our type defs, and we can then make the get recipes query, which is going to, instead of having an ID being passed as a parameter, it's going to have an amount, and it's going to return a list of recipes. So we can go in here, do a comma, and make another asynchronous function called get recipes. We're going to ignore that first parameter, and instead of ID, we are then going to get the amount out of the arguments. This is going to be very similar syntax to the thing above, but we're going to return await. And then we're only using this await statement because the Mongoose functions we call to the right here are promises. And so we have to wait for them to be fulfilled. So I'm going to say recipe.find. And this is all in the Mongoose documentations where you can kind of find some of these more complicated queries, but some of them are kind of common knowledge. For example, .find then .sort is super common knowledge for working with things like I want to see the oldest 10 posts or the newest 10 posts. So you can say .sort. You can use that created at date, or that created at property we have, and then say -1, which means show me the most recent posts. 1 would show you the oldest posts, but -1 is going to give us created at the most recent. And then we can limit the amount of things are returned by this specific query. So I'm going to say limit based off the amount there. So you can imagine if this amount was 5, it would only show us the most recent 5 recipes. If this amount was 100, it would show us the most recent 100 recipes. And so this is really showing us the power of Mongoose, is we can create these more complicated queries just based off the Mongoose model functionality. We don't even have to do anything else for this. And so you could have a social media application that has recipes, for example, and this is the entire query you need for showing like the most 5 recent recipes or something along those lines. So if we go back to our type defs, we'll see that we are done with the reading part. We're able to read recipes and we're able to get recipes. Now we're going to work on the mutations down here. So let's start by getting the create recipe done. We're also going to make this asynchronous, and we're going to call it create recipe. We're going to ignore that first parameter because we're not using that parent object. And then we are going to destructure the recipe input like this. So recipe input itself is an object because if you go to your type defs, it's going to kind of look like what I'm highlighting here. It's going to be an object with a name and a description. And so we can destructure that object by using a colon and then getting the properties out of that object. For example, name and description. This allows us to take the recipe object here and then get the name and then description out of it as parameters. So when we create recipes, we're actually going to create them based off of the Mongoose model we made. And so we can make a new Mongoose model by saying const created recipe is equal to new recipe. And then this recipe is actually the Mongoose model, just so that's super clear. And then we're going to pass in all the parameters that our Mongoose model might need. So our name property inside the Mongoose model has to be equal to the name, which is passed as a parameter here. Then the description property is the passed in description like above. So it's kind of matching this to this and then this to this. We can then make the created app be the new date. So this is just using some JavaScript date syntax. You don't really have to worry about this, but this is a great way to get the ISO string of a date. And ISO strings are pretty much a standardized way of getting dates, for example. Programmers don't know much about getting dates, but that's okay. We can just use this function here, and we can use thumbs up and initially set it to the value of 0 and use thumbs down and set it to the value of 0 as well. So this is when we create a new recipe where we would expect like the thumbs up and thumbs down to be 0, right? This code right here is just setting up our model. We haven't actually saved anything at this point, which is super important. We're going to then get the result from a save function. So we're going to say created recipe, which is an instance of our recipe model, and say .save. So this is saying save this newly created schema or model to our MongoDB database. So this is where that MongoDB saving happens. And then if we go back to our type defs and look at what this create recipe returns, you'll see it returns a recipe. In order to return the recipe, something we can do here with our result, which is kind of common syntax, is you can take the ID, set it equal to the result.id, and then do res.underscore.doc. This is kind of strange syntax, but it's pretty much saying take all of the different properties of the result and show them by saying ._doc. It's kind of strange, and I don't know why it's still like this, but this is an easy way to show all those different properties that are going to pretty much show what our recipe is, because this ._doc is getting us that data from the Mongoose recipe, which is then going to kind of show all the different properties like you'd expect with a name, description, created at, thumbs up, and thumbs down. Those are all being shown in this return statement here. And by the way, guys, I know that some of this backend code can kind of be strange and confusing. A great thing you can do is you can do like console.log res._doc. This will show you a great example as to what's happening. But if you just want to trust me and trust the code, that's great too. But if you want to do some console logs wherever you want, you should get interesting insights as to how everything's working together. All right, so our create recipe is finally done. We create an instance of the Mongoose model here. We save that model to our database, and then we return the recipe to our Apollo server resolver. So it's all 3 steps there. We can then work on the async delete recipe, because if we go to our type defs, you'll see that this delete recipe is the next one. And we want to delete based off of a certain ID. So again, ignore that parent parameter initially with that underscore. And then from our arguments, we're going to get that ID like we've seen before. So the basis of the delete is going to use a Mongoose function called delete1. So we can say await recipe, which means look at all the recipe models, and then delete 1. You can pass in parameters based off how you want to delete something, how you want to filter the things you want to delete. For example, we can filter by saying the underscore ID, which means the kind of MongoDB provided ID. We want to delete that based off the ID here. We're pretty much saying delete a recipe and delete it based off of the ID of that database model. And so if you do some research online, you'll find that delete1 returns an object with 3 fields. The one field I'm going to use in this video is the deleted count, which shows the numbers of documents deleted. So if we go over to this, we know that this await statement is going to return us an object with 3 fields. So we can put parentheses around it, and then to get something out of the object, we can say dot deleted count. So that deleted count is going to give us a 1 if something was deleted and a 0 if nothing was deleted. So we can kind of save this as a const was deleted, just to kind of abstract this out a little bit. Is if something was deleted, then it's going to be a 1, and that's going to be true. And remember, this resolver is going to return a Boolean. And so we can just return this was deleted, and maybe move this comment over here. Because if it's a 1, then it's going to be true. It's going to say, hey, this was true. We were able to delete it. And it's going to give us a 0 if nothing was deleted. I know this is a little in depth just for this tutorial, but this is a good example of how you can show different functionality to your user based off whatever you get from your Mongoose, for example. And so we're expecting a Boolean here, and so that is great. Now we can get started on creating our editing for the recipe. So we can say async edit recipe, again, ignoring that parameter for the parent, and then we're going to get another ID here as well. But with the edit, remember, we have this recipe input as well. And so what we can do is we can say ID, comma, recipe input. Then from here, we can destructure the recipe input like we did when we did create recipe. So we can say colon, then all the properties we want to use, such as the name and the description. Now our parameters have access to both the ID and the name and the description being passed in. So I'm going to do a very similar syntax to above. Delete1 has a very similar syntax to another Mongoose function called update1. So I'm going to say const was edited, kind of like how we had was deleted above. And I'm going to say await recipe. Remember, this recipe is that Mongoose model. I just want to make that super clear. And so since it's that Mongoose model, we're getting new functionality such as update1. Update1 takes in 2 things. The first thing is the filter based on how do you want to update this thing? Well, we want to update one with a certain ID is how we're doing it for this video. So we're saying that underscore ID, which is that MongoDB created ID, to filter it based off this ID we have here. And then, okay, we're filtered to the correct thing we want to update. Now, what properties do we want to update? Okay, well, we're going to pass in an object. We're going to say, well, I want to update the name with the inputted name here. You'll see it's going to light up now. Then I want to update the description with the inputted description here. You'll see they're both lighting up. And so this huge await statement here is eventually going to return an object similar to the delete1 syntax. And so it's going to instead be .modified count instead of .deleted count. And it's going to similarly give us a 1 or a 0. And so we can even copy this line at 31 if we want. Instead, it's going to be was edited. And it's going to give us a 1 if something was edited and a 0 if nothing was edited. A good example of when you might get a 0 is if your ID doesn't exist in your database. I'm giving you guys very simple create, read, update, delete stuff here, but you can also do things like check if there even is something to update. It kind of all depends how you want your API to work and how you want to throw errors or do something like that. This video is just a basic understanding of creating that first create, read, update, delete functionality with MongoDB and Apollo server. And you guys might be surprised, but we have fully created the create, read, update, and delete functionality now. So now we can go back to our terminal and run npm start to get our server started. And so you should go to localhost 5000 and then press query your server here. So now you're in the Apollo server studio, which allows you to make GraphQL queries from your web client. So if we go to the left here and we pressed on root, we're going to be able to create some queries pretty easily. The first thing I want to do is I want to create a new recipe. So that would be a good example of a mutation. So you can press mutation here, and then we can press on the fields create recipes or create recipe. I want to get the recipe arguments, and I also want the name and the description. And then if I go back, I want to also get all these fields back. So you'll see it's pretty easy to create these GraphQL queries when you're working inside of the Apollo Studio because it kind of knows what you want to do. And so this is an example of what the variables would look like for the recipe input. So I can have a name such as the Cooper Codes recipe, and then the description, which I'm going to set as a string, which is going to be, this is my recipe description. And so when we run this mutation, what's going to happen is it's going to run that code behind our create recipe resolver. So like we made before, it's going to create that Mongoose model. It's going to save it to our MongoDB database, and then it's going to return something, which we're going to see on our actual web client. So you'll see we got a status of 200, which is super good. If you didn't get a 200 status, make sure that your MongoDB link is 100% correct. So if we go back to our cluster, we can press on browse collections right here. And we're going to find that this created a MongoDB model inside of our database, which is super great news. That means that our Apollo server mutation went on to actually create real MongoDB data, which is super great. Let's try to see if we can copy this ID. So make sure you copy this ID right here, and we're going to go back into our client here. The cool thing about this Apollo server client is you can make a bunch of different tabs. So we're going to keep this create recipe tab, and in a new tab, I'm then going to do an edit recipe. And so I can go in here, I want to receive a recipe input, and I want the name and the description like this. Looks good. And this is just going to return us a true or a false. So it doesn't have any brackets on the inside. So the ID is going to be that ID we just copied over from our MongoDB Atlas. And let's make a completely different name. Let's say Thanksgiving dinner. And then description. This is now Thanksgiving and not Cooper Codes recipe. So if we run this edit, it's then going to give us a true, which based off our code means that there actually was an edit that got processed on our database. So if we go back to our MongoDB Atlas, we're going to find that the object ID is the exact same, and the name and the description were both changed, which is super great news. This is actually really interesting because it shows that we didn't delete the object and then make a new one in replace of it and have to do some weird stuff like that. No, we just changed the name and the description, and everything else around it stayed the same, which is super cool. So let's just say I don't like Thanksgiving very much. I might want to go and delete this recipe. So let's go back to our Apollo Studio here and then press a new tab where we're then going to create a delete recipe. So go to your mutations, go to delete recipe. Delete recipe is really simple because all it wants is an ID, and it's going to give you that true or false based on whether or not that thing has been deleted. So I'm going to pass in the ID from our Thanksgiving object over here. So copy this, make sure it's the same one, and then run the delete recipe. Okay, so this is saying it's true, which means that something has actually been deleted. So if we refresh our collections over on MongoDB, and super important there is you want to manually refresh your page. MongoDB isn't cool enough to show it to you automatically. And you'll see we don't have any recipes anymore because we deleted it, which is super cool. And so I've shown you guys how to delete things, edit things, and create things, but I haven't shown you guys how to read anything. So let's go back to our first tab where we create the recipes and just run a couple of recipes so you can get your database filled up with a bunch of information. So I'm going to say Cooper Codes recipe, and I'm going to run it. I'm going to name one subscribe to Cooper Codes, especially if you made it this far. I'm going to run that. So we make that. And I'm going to say, I'm going to call this one a tasty bite, which is the most hilarious joke you've ever heard, I'm sure. I'm just going to say this is a different recipe description. I'm going to run that one, and we should have 3 or 4. Let's go look. So we now have 3 different recipes inside of our database. We got the Cooper Codes recipe, the subscribe to Cooper Codes, and then a tasty bite. So let's try and copy this tasty bite ID. And I actually want to get the data of this ID specifically. So let's go back to our client, and I'm going to make a new tab. Inside this tab, I'm going to run a query, and I'm going to run this recipe query here, where I'm going to add the ID and I'm going to add all the fields I'd expect back. So inside the variables that are made for us automatically there, I'm going to pass in this ID and it should show us a tasty bite on the right here. There we go. So we got a 200 and all we passed in was the ID. The Apollo server is showing us all the different data related to that ID, which is super great news. Let's say I had a feature in my web app where I only wanted the name and the description. You can change your GraphQL query over here. So let's get rid of everything else. to show just the name and the description of a certain recipe. So we can keep the ID the same, run it again, and you'll see it shows you that name and description only, which is super cool. But what if we wanted to grab a list of recipes, for example? Well, we can make a new workspace over here, go back to our queries, and then instead add this get recipes. So get multiple, right? We can add in all the different fields we want, and we can also add in the amount here. So I'm going to make the amount equal to 3. And you'll see it's going to show us the most 3 recent recipes that we added to our website. You'll see the Tasty Bite was the one we added most recently, so it's showing at the top. Let's say I only wanted 1 recipe from the get recipes. You can still do that, where I'm going to run it here. And when I only ask for 1, it's going to show me just this one. If I want to ask for 2, for example, it will show me 2. And let's say I set this limit to something ridiculous, like 100. You'll see that the code isn't going to break there either. It limits it to 100, but it's not expecting 100 results. So that's an important distinction to make there. And the cool thing is, even though this is returning a list of recipes and it might seem more complicated, you can still change your GraphQL query to only ask for certain things from everything in that list. For example, I can delete everything except the name and the description, run the query again, and it will show me all those different recipes, but only with the name and description from each one. So that's pretty much the full video. We created an entire API here in a relatively fast amount of time. You can create a similar system to really manage any type of content you want. You know, whether it's a recipe application, whether you're creating like an apartment finding application where you add apartments, you delete apartments. This video should be super helpful in understanding how to create that system, especially in GraphQL and Apollo Server, for managing all that data. I plan to make a video soon where I make a full stack application showing off how you can do things just like this, except with actual user authentication. For example, only a certain user should be able to delete their own posts, for example, right? And so if you're interested in that type of content, feel free to subscribe, give this video a like if you liked it, and thanks so much for watching.